Traditionally, when we were working with any sort of machine learning as far as images, we would go ahead and not just take the raw images and somehow feed them into our machine learning algorithm. Instead, we would go ahead and extract some features. So let's look at an example. So let's say that you had an image like this. Okay. One feature we might want to get from this is horizontal lines. And so we could get that by doing an operation that would come up with and identify the horizontal lines. And then this is the feature that we might feed in to our machine learning algorithm. Okay? Under the assumption that this is just way too complicated for it to deal with. Or if this was our image, then again, we might extract all of the outlines. So that would be one of the features that one would do, would be extract the edges from an image and then feed in those edges. So we're going to look at how you can use convolutions to do things like extract edges. That is not exactly what we're going to be doing with neural networks, but it's going to lead us in to how we use convolutions with neural networks and gives you an idea of how they were actually come up with. Let's look at a horizontal edge detector for a given input. So I'm going to look at a 5x5 input. So we have a 5x5, and we have some particular ones and zeros. So we're actually going to just use a black and white here. Or if it's grayscale, we don't have any gray. So let's look at what we've got. We've got 1 here, and we've got zeros everywhere else. I'm not going to show the zeros because it's a little easier to see pictorially if we just have zeros be blank. And we want to come up with some horizontal edge detection for this. So we are going to use what's called a convolution. That is, we are going to convolve a matrix with this original matrix. So we are going to use a 3x3. We'll talk about that a little bit later. And in our 3x3, we're going to have the following values. First question is, what does convolving mean? Okay. Well, here's what we're going to do. We're going to take, let me say, that this is what's called a kernel, a convolution kernel, and we're going to convolve this matrix with this kernel. So what does that mean? Well, we are going to take this matrix and we are going to overlap it with here. And what we do is do a pointwise multiplication. So we're going to multiply this by this, 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 and add them all together. So basically what we're going to have is a sum of 9 multiplications. So pointwise. So let's try this. So we're going to go ahead and take this one here, and we're going to come up with zeros here because the input is 0. So 0 times -1, 0 times -1, 0 times -1. Here we're going to have 1 times 2, 1 times 2. So we got 4 so far, 2 times 0. And then -1 times 1, -1 times 1, 0. So we got 4 plus -2 is a 2. Okay. So we're going to end up with a 2 here. What does this represent? This represents, this is the convolution centered at 2, 2. And then we move this kernel over 1. And so instead of looking at centered at 2, 2, we're going to look centered at 2, 3. So if we look centered at 2, 3, everything's going to be 0 except these two. And so that's going to be 2 times 2 plus 1 times -1, which will be a 1. So we have a 1 here. And this is going to be at 2, 3, centered. And we move it over again. Since this is all zeros, the total is going to be 0. Now we take this matrix and multiply it down 1. So now we're centered here at 3, 2. And here we're going to get 2 times 2. So let's try. We're centered here. So we're going to get 1 times -1 plus 1 times -1 is -2. This is going to be 0. 2 times 1 is 4, so our running total is 2 now, 0. Negative 1, negative 1, negative 1. Our running total was 2, this is a negative 3, so that's a negative 1. And let's keep just going. So this is going to give us, these parts are going to give us 0. Negative 1 plus 2 is 1, plus negative 1, negative 1, negative 1, negative 3 is 1 plus negative 3 is negative 2. Here, zeros, zeros, negative 1s. Here, negative 1 is negative 2, plus 6 is 4, plus negative 3 is 1. Here, negative 1 plus 6 is 5, plus negative 3 is 2. And then finally here, zeros in the top row, 2, 2, 2 is 6, negative 1, negative 1, negative 1 is 3. And let's just look, for instance, that this 3 here is centered here at 1, 2, 3, 4, 1, 2, 3, 4. So we went from being centered at 2, 2 to centered at 4, 4, which is how we ended up with a 5 by 5, taking us now down to a 3 by 3. How can we understand this? Well, how we can understand it is something like this. If we're in an area that is all the same, for instance here, it's all whites, this turns out to be 0. If it's all blacks, that would also turn out to be 0. No edges there. Okay, so we can see in a uniform area that we end up with a 0. Where we get positive values is if we have 1s in the area where we're centered and 0s either above or below. So for instance, in this case, we have 1s here and 0s above. And so that is giving us a measure of 2. As we move over 1, we have less of that, right? Because we have an area of 2 by 3 where we have no horizontal line. But here we've got some horizontal lineness because we've got some movement from 0 to 1 here to here. Okay. Similarly, we got movement from 0 to 1 here to here. So we would expect these areas to be high. And that's exactly what they get. They are high. So we have a 1 here because mostly this is a big blob of 1s, but we have a little bit of horizontal. We have more here and even more here. So we can see 3s are fairly large. What's the largest that this would ever get, right? Well, that would in fact be 6. So we can imagine if we just had a single 1 pixel high line, we've got white space above it and white space below it. So we would end up saying it's 2, 2, 2, which is 6, and then these would be 0s above and 0s below. Alternately, if we had a white line, then this would be 0s, and then black above and black below would be negative 6. So negative is telling us a white line with black around it. Positives are telling us a black line with white around it. So here, when we're centered here, this looks like a white line with black below it. Here, it's a black line with white above it. So that's why this movement from negative to positive here. So we talked about the fact that this got smaller. We went from a 5-5 down to a 3-by-3. How could we maintain that 5-by-5, right? The problem really was that our kernel was completely fitting on here, so therefore it had to be centered, not at 1-1, but at 2-2, and could only be centered down at 4-4, so it got smaller. So what we can do is, we can go ahead and say, we're going to go ahead and add some more entries, such this entry is centered at 1-1, and this entry is centered at 5-5. How are we going to do that? If we center this at 1-1, then we've got these 4 pixels from here, and then missing pixels along the edge. What do? Well, we do what's called padding. Okay? We can pad in a variety of ways. The most common way is just enough so that we could center at the extreme edges. So in this case, we'd add 1 pixel all around. One question comes up, what do we fill it with? So let's look at this. So for padding, our options are none, which is what we did. Right? That was what got us from a 5.5 to a 3.3. We can do half padding, which is enough to get us so that the extremes center at the edges of the original. And so if we do that, we retain the size. Okay. So this size was 5.5. Half padding, like this, which we'll look at in more detail in a moment, will retain the size. If we do no padding, what happens? Well, it gets smaller. It gets smaller by how much? Well, first off, let's look at the convolutions, right? We saw a 3x3 here, but it could actually be a different size. Convolutions are always going to be odd sized. So we do an odd number, and the reason we do an odd number is so that we could center this on a pixel. If we had an even number, we'd be off. So we're going to have an odd number. And then what happens when we don't have any padding? Well, what happens depends on the size of the kernel. Let's say we just look at this as W by W. Well, in that case, if we have this is the height, and this is the width, and let's call this K. So this is K by K. In this case, something of the form width by height goes to something smaller. Well, how much smaller? It depends on this width. So we're going to basically lose this amount on the left, this amount on the right, this amount on the bottom, and this amount on the top. How much is that? That's going to be K over 2. So we're going to have K over 2 on each side. K over 2, the floor of K over 2. So we're going to take the floor of K over 2 and multiply that by 2. And similarly, the height minus K over 2 times 2. When K is odd, which it is, then this just becomes the width minus K times height minus K plus 1. So in this case, we went from 5 by 5 to 5 minus 3, which is 2 plus 1, to 5 minus 3 plus 1. So that became 3 by 3. We also have the ability of doing full padding. So that would actually say, take this entire kernel and move it up so that 1 pixel of it is touching 1 pixel here. Okay. And then add padding throughout. And that's called full padding. And here, we're going to actually get bigger. We also have the choice of what do we pad with. We can pad with zeros. And just to let you know, by the way, zeros and half padding is the most common. We're just covering everything else for completeness. We can pad with copy from the edge. So basically just copy what is on the edge over. Or we can pad with copy from the other side. So it's like a wraparound universe, like if you ever played Space Wars or Asteroids. Let's go ahead and go through this operation, assuming that we use half zero padding, because half zero padding is almost always what you're going to be using, because you really don't want, what we're going to be doing is doing convolution, and then we don't want the size to get smaller. We'd like to treat a 5 by 5 and then continue it on as 5 by 5, and we maybe do more convolutions in the future and come up with and continue on it to have it be 5 by 5. But there are certain circumstances where you might not want to. And we're going to do zeros, so this kind of looks right, because these are all zeros. We've said, again, that if we have zeros, we just don't show it. All right, so we're going to center this at 1, 1 here. So therefore, we've got a bunch of zeros, a 0, and 2 1s. These 2 1s are going to map to these 2 1s here, so we're going to have a -2. and again, mapped at 1, 1. Let's go ahead and map at 2, 1. Let's go ahead and center at 2, 1. So we've now got, again, only 2 1s. They're going to be these two, so that's going to be, again, a -2. We go over one more, so now we're centered here. We're centered on this guy, so we're doing this. And that's going to be all zeros. And here, centered. So we centered here, we centered here. I missed this with centering here. So we're actually centered at this guy. So this guy is going to be 1 times -1. And then we have centered here, which is 0, and then here, which is 0. So this guy over here. We've got more to go. We want to center here. So that's going to be 1 times 2, 1 times 2, 1 times -1, 1 times -1. So that's going to be a total of 4 minus 2 is 2. We center here. We have 2 -1s at the top, 2 2s in the middle, and 2 -1s at the bottom. So that's going to be a total of 0, which makes sense because horizontally everything is all even. And again here, for the same thing, centered here, all even. Here, we're actually in some sense identifying a line because we've got zeros along the edge here, and so there's a line between the 1s and the zeros. Maybe we would have been better to use edge padding rather than zero padding in this case, because basically zeros on the outside may mean we're all of a sudden seeing an edge seeing edge basically right at the end, an edge right around the borders. So in this case, so we didn't see an edge at the top here because these were already zeros, so we're not adding an edge, but we're adding an edge here. So down here we've got 2 -1s and 2 2s, so that's going to be a total of 2. Centered here, we have 3 -1s, 3 positive 2s, and so that's a total of 3. Again, 3 -1s, 3 positive 2s is a 3. So we did centered here, we did centered here, we did centered here, now we're centered here. Same thing, of a 3. And as we move over now here, 2 -1s and 2 positive 2s, so that's a 2. We were here, so we're centered here, 4, 5. So we've got 2 2s and 2 -1s, so that's a 2. And now centered here, just 2 -1s, which is a -2. And then centered here, it's going to be zeros, and centered here is going to be zeros. Let's look at maybe 2s, absolute value of 2s and 3s to signify our lines. So where are we saying we have lines? We have a line here, which makes sense because there's a boundary between here and here. We have a line here, which makes sense because there's a boundary between here and here. We have a line here, which is this boundary between here and here, and a line here, which is really the same boundary looking at it from the opposite approach. So we've got our edge detector, and now we've looked at using half padding, padding with zeros, to get us from a 5, 5 to maintain to a 5, 5.